All right, everybody, here's the solutions to this angled forces practice quiz. In this problem, it looks like a kid is pushing down and to the left on a lawnmower. He's pushing with 50 newtons at 42 degrees. He's accelerating to the left. We got to draw a force diagram and determine the normal and the friction force. I kind of drew a little fake lawnmower over here on the right just because it's kind of hard to draw in the picture and see everything. So I'm going to go ahead and draw my force diagram first. On the lawnmower, there's going to be gravity. There's going to be a normal force. There's going to be some kind of friction, even though it's on wheels, against the grass. And this kid is pushing down into the left on it. I'm going to go ahead and draw my triangle here. So it looks like this is our angle theta right there. I'm going to go ahead and draw my triangle. So he's pushing down into the left, so I need an arrow to the left, and I need an arrow downwards. So if this is our angle, I'll call it FA, then right up here, that is going to be FA, that's the adjacent leg, so that's going to be cosine theta. And then I'll kind of put a little dot here, so that's going to be FA sine theta, and that's pointing down because he's pushing down into the left. Now I'm going to go ahead and start solving for the things that we need to in this problem. I'm going to start off with horizontal forces. The object is accelerating, it says in the problem, to the left at 9.9 meters per second squared. I'm going to start off with F net equals m times a, and then I'm going to look at my force diagram and realize I have two horizontal forces, FF to the right, and I've got FA cosine to the left. So I'm going to make the direction that it's going the positive direction, so I'll make FA cosine theta positive, subtract off friction equals m times a. That's the important step, is getting that. After that, that becomes just a little bit of algebra. So the applied force is 50 newtons. Then it's going to be cosine of 42 degrees, subtract off friction, which we don't know. The mass is 25 up in the problem, and our acceleration is 0.9. So if you do 25 times 0.9, and you subtract off 50 times the cosine of 42, and then basically divide both sides by -1, we should get a friction force equal to 14.66 newtons. Now when we solve for the vertical forces, the key thing here is that the lawnmower is accelerating to the left. It's not accelerating vertically, so my acceleration is 0. This is going to be true for all of our problems where people are pushing things down and to the left or up and to the right, and they stay along the ground. So I'll start off with F net equals m times a, and I look at my force diagram and I find all my vertical forces. So Fn up is a vertical force, gravity down is a vertical force, and then here Fa sine of theta points downwards with gravity. I'm going to assign Fn to be positive upwards. So Fn, and I'm going to subtract off Fa sine theta. Then I'm going to subtract off Fg, that's also pointing down, equals m times a. At this point, it becomes number crunching here, so Fn minus 50 sine 42 degrees, and then Fg is going to be mass times 9.8. So 25 times 9.8 is going to be 245 newtons, and that's going to equal 0. So this is 25 times 9.8. That's where I got the 245. And then you're going to add both these quantities to both sides, to the right side, because they're both negatives or minuses on the left side. And you should get an Fn equal to 278.46 newtons. The way I know my answer is right is because of the fact that my Fn has increased. So 25 times 9.8 is 245. If I'm pushing something into the ground has to push up with more force to hold it there. Therefore, my Fn should be increasing from Fg. Next problem, I am hanging a Thanksgiving sign from 2 ropes. All right, we got to figure out the tension in each cable. Start off with a force diagram that's Fg. This rope is going to pull to the right. My FA is going to pull up and to the left. then I'll draw my triangle here with the angled force, so like that. So then this is going to be FTA, that is my adjacent leg, so that's cosine of theta, and this is going to be FTA sine of theta. So I've got my force diagram. Our goal is to solve for the tension in both ropes. I'm just going to start off with, I don't know, in this case I'll go with horizontal. I don't know if there's any really rhyme or reason why you should choose a specific one. I'll just go with horizontal. The acceleration everywhere is 0. And we start off with F net equals m times a. So vertically, I see my vertical forces as FTA sine, oh sorry, I'm doing horizontal, I should say, sorry. So my horizontal forces are going to be FTA cosine theta and FTB. So I'll just make I'll make FTB positive because I get to choose. FTA cosine theta points the opposite way, so I subtract it, and my acceleration is 0. I can rearrange and say FTB is equal to FTA cosine theta by just bringing this to the other side. I don't know FTA. All I know is the angle, so it looks like I'm at a point here where I can't go any further. So it looks like I should have started off with vertical forces. So I'll come back to that part over here. So vertically, I go up to my force diagram and I say, all right, what are my vertical forces? It looks like I have FTA sine theta and FG. So then I'll go back down here. And I've got F net equals m times a. So FTA sine of theta minus FG equals m times a. And again, my acceleration is 0 because this sign's not moving. So FTA sine of, let's make sure this is yeah, in the directions it says it's 40 degrees, I should say. So 40 degrees minus Fg, and Fg is going to be the mass in this problem, which was given 20 kilograms times 9.8, and that's going to equal 0. So then I would do FTA sine of 40 degrees, and I would bring 20 times 9.8 over to the other side, so it'd be 196. And then FTA is going to equal 196 divided by the sine of 40. So 196 divided by the sine of 40 gets you 304.92 newtons. Now that we know that, we can go up and do FTB equals 304.92 times the cosine of 40 degrees. And FTB is going to equal 233.58 newtons. So I had to bring this and bring that up and go into there to be able to solve that. Let's head on to the last problem. This is a kid going down a ramp. It looks like he's 30 kilograms. And he's going down at a constant speed due to friction. We've got to draw a force diagram and determine the friction force and the normal force. Our force diagram on the child, we've got gravity pulling straight down on the child. We've got the normal force up and to the left perpendicular to the ramp. And then we have a friction force the opposite way he's moving there. And then what we want to do is break up our Fg into an angled force, and it turns out with geometry we know that this angle right there, theta, is the same as this angle here by 35 degrees. So that means that this is the adjacent leg, so that's Fg cosine theta, and this is Fg sine theta. So again, that's the most important part, is knowing how to break up Fg into its components there. And we are going to solve for the friction force. If you remember, friction force is this direction. It's parallel. Basically, I'll put it in green here. It is this plane horizontal. It's horizontal. So I'm going to go ahead and solve horizontally. F net equals m times a. I'm going to make the force going down the ramp, the direction the kid's going is positive. So that'll be Fg sine theta minus friction pointing the opposite way equals m times a. Our acceleration, because they're going at a constant speed, is 0. And at this point, we start plugging in numbers. So this, of course, right there was the all-important step. So I will do 30 times 9.8 times the sine of 35 degrees minus FF equals 0. And then mathematically, we could just bring FF to the other side, and FF is going to equal 30 times 9.8 times the sine of 35 degrees, which is 168.63. And our last step is to determine the normal force. The normal force will go vertically. Acceleration is always 0 vertically on a ramp. That would mean, if it wasn't, that would mean they'd be either being lifted off the ramp or digging into the ramp and breaking the ramp. So even though there could be an acceleration, it's always going to be horizontally on a ramp. Vertically, this is the plane right here, this angled plane. Fn almost always tends to be a vertical force. So we'll start off with F net equals m times a. I'll make upwards, Fn the positive direction, so Fn minus Fg cosine theta, because it's going the opposite way, equals m times a. And then Fn minus 30 times 9.8 times the cosine of 35 degrees is going to equal 0. And then to get Fn by itself, all I would do is just bring all that other stuff to the other side. So basically Fn is equal to 30 times 9.8 times the cosine of 35. And I get 240.83 newtons. All right, I hope you guys did well in the quiz. If not, I hope that this video was able to help you out. And you should have a quiz coming up soon on this, probably tomorrow. Or I should say probably on Monday. I will talk to you soon.